Hi, my name is Robert Burns. I'm a technical leader with Cisco. So in a very high level, we can see here we've got a lot of new things and new concepts within ACI. At the very high level, we've got the concept of a tenant. And a tenant can be a customer, can be an internal group, a business unit. Really, that's going to be an entity that we can manage and monitor in terms of controlling who can access it. So if you have a multi-tenant environment, if you're a service provider, you can have thousands of customers being different tenants. This gives us some isolation between who can access and what policies are available. The next level down we've got our private networks. Our private networks are really the same concept legacy-wise as a VRF or a context. So in ACI terms, we call this a private network, but you're going to hear these names, context and VRF, sometimes used interchangeably. Really, this is a routing instance, right? We can have a layer 3 forwarding instance, and this allows us to separate our routing domains. So inside of a single tenant, I may want to have a development network and I may want to have a production network. So I can have a private network for each. What this also allows me to do is reuse addressing. So if I have a subnet B inside of my private network A, on private network B, I can also reuse that. So this is a complete separation of our addressing. So again, between multiple tenants or even within a tenant, I can reuse my IP subnet addressing space. The next one down, we also have a bridge domain. So a bridge domain is really a combination of a switch and a VLAN tag. And it's a bit more complicated in today's where now we have distributed switches where they span multiple logical devices. Well, that's similar to our bridge domain. We're going to contain our multicast and broadcast traffic within a bridge domain. And with our ACI fabric, we have multiple switches and leafs. They can span multiple leaf switches with our bridge domains. Below that, we have our IP subnets. Okay, we talked about our IP subnets. They're going to belong to a bridge domain, which rolls up into our private tenant. Again, we can have multiple reuse there. So if I want to recycle that subnet B from that first bridge domain, I can do so as long as they're separated by a different private network. And the very last concept is a concept of an endpoint group. This is probably one of the most important concepts ACI offers. And I will go into more detail, but at a very high level, our endpoint group is where we apply policy. And we call these policy contracts. Endpoint groups are going to be collections of like endpoints. So I might have a bunch of web servers all collected together, treated with similar policy. So when you're designing what goes in an endpoint group and when do I create a new endpoint group, just think in terms of policy. So let's talk a bit more about our tenant. So really, our tenant is a logical container. And this is where we're going to contain our application profiles that we talked about in the previous lesson. So we're going to also be able to control who manages and how they manage it. So if you've got different units of business that want to manage each different tenant, we can do so. We can give people certain access so they can access this tenant and they can manage it accordingly. Now there are 3 default tenants that come with ACI, and I'll talk briefly. It's called the management tenant. And this is where we define policies for the managing of our physical devices, so our leafs and our spines and our APICs. So if I want to define addresses for out-of-band or in-band, that's where I'm going to define them, is underneath my management tenant. If I want to define policies on who and which protocols I allow to access my management infrastructure, that's where my management is going to be configured, underneath the management tenant. The next one we talk about is the infrastructure tenant. This is another specialized tenant, really for the infrastructure. So these are going to be policies for the control plane back end of ACI. So if I need to define our TEP address pool, our tunnel endpoint pool, our infrastructure VLAN, which allows my leaf switches to talk with my controllers and my spines to talk with my controllers, all that is done over the infrastructure network. So we don't have to worry about too much that we're going to do here. Really, we'll come back to the infrastructure tenant when we talk about the application virtual switch. There's a couple extra things that we have to configure, which we'll cover in a future module. And the last one is our common tenant. And the common tenant is a special one. Again, it's there by default, but it's where we're going to define any type of shared resource. So you might have endpoints such as an Active Directory server, domain name system, other type of authentication servers that might be shared across multiple tenants. The common tenant is where we're going to define those type of shared resources. The next concept we'll go a little bit deeper is our private networks, or VRFs. And really, this is just a unique layer 3 forwarding instance. So think of every context as being its own routing namespace. We can separate our layer 3 addresses here. So if I want to recycle addresses, no problem, we can do that. And this is going to be very common. If you have a multi-tenant environment, you can't control what tenant A is going to configure for their addresses. By separating them by a tenant, they're automatically going to have each their own private network, which allows them to be in their own routing namespace. Next concept we'll go a little deeper is our bridge domains. So like we said, this is where it's going to limit our broadcast and flood traffic, just like we would in traditional networking, but this can span multiple leaf switches. Now by default, we operate in what's called a proxy mode, where ACI is going to know where every single endpoint is configured, so we're not going to use flooding by default. Now in the event you have to have flooding enabled, and a case would be if you had your default gateway outside of the fabric, we can turn on flooding for that bridge domain, and then we behave like a traditional networking would, where we'll see flooding. But if we can avoid it, disabling that flooding action by default, if our default gateway does exist on the fabric, becomes very powerful. We've now eliminated a lot of unnecessary traffic. Application profile. We've talked a bit more about this back in our last lesson, and this is really a logical container that is going to contain our various endpoint groups. So our application profile, you're going to have one of these for every one of your applications. So I might have a movie portal that may be made up of web tiers, application tiers, and database tiers. That would all be contained within my application profile. So just think of your AP as being your collection of EPGs. The other important aspect about the application profile is monitor for health. So this is another unique thing that ACI is going to do for us. Rather than looking at the health of a particular server or virtual machine, we can now look at our application health collectively in terms of the links, in terms of how many endpoints are online, and their various forwarding states. We also can apply various levels of quality of service. So if you have a tiered approach where you have customers that maybe pay higher amounts for a higher level of service, we can do that at the application profile level. So we can apply a higher level where it's needed. So looking a little bit more about our application profiles here, we can see I've got a CRM application here, which is made up of a very common 3-tier application. So I've got 3 application endpoint groups, one called web, one called app, and one called database. So each of these tiers, I've got a bunch of endpoints inside of these various tiers. So each one of these, service A, service B, one of these could be HTTP, one of these can be HTTP secure. All these endpoints are going to be treated the same way in terms of who they can communicate with. Now, we talked about those inbound and outbound policies. That's what we call our contracts, and that dictates which protocols, which ports, source, destination addresses, very similar to how a firewall is going to operate. That's all natively built into the fabric. Now, the very most important part, again, is our endpoint group. And this is where we apply policy. So if I want to restrict how 2 endpoints are going to communicate, they have to be in different endpoint groups. If I put them inside the same endpoint group, they can communicate freely and openly. We can't restrict it at that level. So when you're deciding how you want to divide up your various endpoint groups, just consider policy. Do I need to restrict any endpoints within that endpoint group? If I do need to restrict them from talking to each other, makes sense that they become their own endpoint groups. So think of our endpoint groups as well as being grouped into a few different types of endpoint groups. We have our traditional application endpoint groups, which is going to be like our web and tier, our application tier and database tier. The next 2 ones are kind of special case ones, layer 2 and layer 3 endpoint groups. And that's where we're going to define where our layer 2 incoming connections or layer 3 incoming outgoing connections to our fabric come. So you're probably going to have some type of router, maybe an ASR connected to your fabric, where your external fabric traffic is going to enter. That traffic will get classified based on however you acquire it, could be by VLAN, could be by IP address subnet, into its own endpoint group again. And again, that allows me to apply policy. I can say all the traffic coming in on VLAN 100, I only want to allow port 80 to talk to my web tier, and you can restrict that. And then lastly is the management endpoint group. is where we're going to define our policies for how we're going to manage the leaf switches. Do I want to allow external users to SSH to them? Do I want to let them talk on any subnet, any protocol? So we can manage that as well if they're endpoint groups. Now, once we know about those 4 types, there's 2 real subtypes to our application endpoint groups. And this is a regular base EPG, just a regular endpoint group, might be called web, might be called app or database. But then we have a special one, and this is kind of a new feature recently added, called our attribute segment. And you'll see this referenced in the topology and in the UI as USEG for microsegment. In this EPG, we can define an attribute. I can say, I want to have all the VMs that have the word HR in the VM name get classified into their own EPG. Or maybe based on their IP subnet coming in, can get automatically assigned into an EPG. So this automatic attribute-based is very powerful. So it's kind of like an auto-classification for endpoints. So here's an example of an endpoint group. I've got an endpoint group here called Web Services. Now inside of my Web Services endpoint group, I'm expecting I'm going to have a bunch of web servers. Some are going to be our standard web servers that are using port 80 to communicate. And then I'm also going to have my secure HTTPS servers, which only allow 443. Now, regardless of these mixing of endpoints, I still have policies defined on what they can talk to. Yes, I may be allowing 2 different ports, but I only want to allow these endpoints to talk to my application tier. And I only want to let my external users talk into here. So regardless, policy is going to be applied the same to all these endpoint groups. We can define multiple ports, multiple source and destination addresses, just like you would in ACL. But these guys, in terms of who else they can communicate with, are going to be unique, the same across both. Now, the other thing to note here is our subnets are not bound to an EPG. So I typically might have a endpoint HTTPS may be in subnet 10.10.11, but my regular port 80 web servers are in 10.10.10. That's okay. We're still going to apply the same amount of policy. These guys are still going to only be restricted to talk to who the contract allows them to. Now let's take a bit more deeper look in these contracts. So these are the rules on what EPGs can communicate with. So we talked about our tenants. We talked about the application profiles being our container. And then we have our various endpoint groups. So I might have an external L2 group coming in there from the WAN. I have an endpoint group called web, one for app, one for database. And then we know we have to have these contracts in between. By default, we explicitly deny all traffic between EPGs. So think of it as being a whitelist. We have to define what we allow to communicate before anything between web and applications can talk together. So that's where our contracts come in. Now our contracts are made of multi-levels of policy. At the very high level, we've got the contracts. And our contracts is really, we give it a group of subjects. And the reason why we have multi-levels of this contract is for reuse. I may have subjects and filters that I can use across multiple contracts. So just because I use port 80 allow, I may want to use that across multiple applications or multiple contracts. So we really have a high level of policy reuse inside of the ACI fabric. So at the very high level there, we've got our contracts. And in our contracts, we're going to define the scope. Where is this contract available? Do I want it available to anybody in the fabric? Do I want to restrict it to a certain tenant? Or do I even want to tie it down to only certain application profiles can access this contract? Once we have our contract defined, we're then going to start making our subject. And our subject, again, is just another layer of policy reuse that we're going to define things like, do I want this communication contract to be bidirectional or unidirectional? Do I want to allow one-way communication or two-way? We're also going to define our insertion point for layer 4 through 7 services and things like quality of service. That gets applied at the subject level. And then our very lowest level is where the actual port level rules come out, and that's our ACL entries, and that's where our filters come into play. So by combining all these together, our filters roll into our subjects roll into a contract. I can then assign that contract, and I can reuse that contract depending on how it's been defined. Now, how do I apply policy to an endpoint? Well, there's a couple different ways. We can apply it by simple plugging in an endpoint. An endpoint gets attached to our network. we see that traffic, we can see the MAC address, we can see the IP address coming in, and we can apply policy to it. We can also hard code ports to an EPG. So we can say all the traffic coming on leaf number 6 on port 11, we can classify that directly into an EPG. And we call that a static path binding. But with VMs like to move around, and they like to go between different hypervisors, which are on different ports. So we are going to allow you to integrate your EPGs into the virtual environment, which I'll talk a bit more about in the future here. So our application gets detected, we plugged in our new VM, it gets attached to a VMware port group, and our APIC admin has already mapped that port group from VMware into a very specific EPG. The APIC detects this attach event, and we're going to push the policy that it belongs to. So because it's attached to a very certain endpoint, we've now pushed that web application endpoint group policy down to that VM. So in summary, we had a bunch of new concepts that we talked about here. The very first one we talked about was our tenant. That was just a logical container for all of our applications. It's also where we're going to limit who can access this specific configuration in terms of roles-based access controls. Next one below our tenants, we had our private network. Our private network is where we had our VRF instance, our contexts, and that's really that routing namespace. After that, we had multiple bridge domains. Our bridge domain is really a delineation point of where we want to limit our broadcast and multicast traffic. It also is where we can change from a proxy mode to a flood mode operation, depending on if our gateway is on the fabric or off the fabric. We talked about application profiles. This is that stateless application where an application profile is simply our collection of endpoint groups. And the very important aspect of the application profile is the collective manner that they're going to be monitored. We can see the health at an application level of all the endpoints that make up that application profile. Our very, very important one I've been stressing is the endpoint group, which is that logical grouping of endpoints. And the one thing to take away is that they share policy. So if I do have to restrict which endpoint groups talk to other endpoints, think about that as how you're going to design your various EPGs. And lastly, those rules that we allow between EPGs, those become our contracts. So contracts can be reused. We can use them across multiple endpoint groups. We can use them across multiple tenants. Defining your contracts, keeping in mind that we want to define once and use many if they share policy. So now we're going to talk a little bit about some of the migration options from going from our legacy networks to ACI Fabric. How do I take my existing network without ripping and replacing and getting sure everything's working from my migration standpoint? So there's a couple options that we've got in terms of how do I take my traffic from my legacy network and get it into ACI into where I'm starting to build out more endpoints. So one of the options is very simple, is I can map in VLAN. So I can say all the traffic coming in on VLAN 100, I want to map that into an EPG. So my example here, in my legacy network, I've got a VLAN 100 here, and that's where I keep all my test applications. So I got all my test applications using VLAN 100. And what I can simply do in ACI is where they connect into the fabric, I can map all that traffic from VLAN 100 into an EPG, and I can call it test, reuse the same name. Similarly, if I had VLAN 200, which was housing all my application endpoints, I can map those into its own EPG as well. Makes it very simple. I can understand VLAN to EPG. It's a very good mapping idea. Now, if that doesn't work, another option you have is you can map to an EPG by a subnet. So if I have my legacy network over here, let's just make sure we clarify this is all legacy. And I may have all my production applications using this specific subnet, 10.10.10. And I may have all my development applications using 10.10.11. And again, these are become a simple mapping. I can say all the endpoints mapped from that IP subnet go into development, and all the guys from this subnet come into my production EPG. So that's another option. You've got flexibility. And again, you can do both. It doesn't have to be limited to either IP or VLANs. We can do either. And now, not losing sight of virtual workloads, we can do the same thing with virtual endpoints. In our example on the last slide, we showed how we had a virtual machine endpoint connect to the fabric through a hypervisor, and the APIC pushed down that web EPG policy. Well, how did it do that? the APIC has a hook into the virtual environment, be it VMware or Hyper-V, OpenStack, any virtualization platform we'll be adding support for. So we can take those endpoint groups on our distributed switches, and this can either be the VMware DVS, or we can use the Cisco version, which is the AVS, or Application Virtual Switch. The AVS is based off the Nexus 1000V, again a distributed switch. When I have my endpoints connected to a port group, perhaps I've got these guys here connected to a port group called database, I can simply map that into its EPG. I create my EPG called database on the fabric, and then all that traffic and policy gets applied. Thank you very much for watching.